Well, thank you for attending the session here on the Internet of Things. We're going to talk about the fundamentals of Azure IoT. Hopefully people aren't in too much of a food coma and can stay awake. I'm going to try and have it be part, talk, but also part demo. So I've got, and we'll go through some of this stuff. There's a board out here by a company called MXChip, and they actually interface with Azure really easily. So I'll go through some of that, so cross your fingers, make sure that the demo actually works. Sometimes the demo gods like to play tricks on us, and things don't work, but we'll see how that, we'll kind of round out the talk with that. So just real quickly, I'm going to kind of some of the things that we'll cover about me and about Lab 651, which I'm one of the co-founders of. Sort of the history and future of IoT. Sort of what's Microsoft's Azure IoT platform, if you've worked with it or not. There's actually a thing called Event Hub, which actually handles, it's been around for quite some time, but it actually sort of handles a lot of the ingestion of all these devices that are out in the field. Kind of go through a little bit about the development environment, and then we'll go through some code demos, and they've got a whole suite. They've got like probably about a dozen different demos you can do out on their site. I selected 3 ones that I thought were kind of interesting and could be done sort of in the amount of time that we're talking about here, and hopefully they work out well. So try and leave some time here for questions. I think we go until 2:40, so hopefully we'll have enough time here and people can sort of ask questions about what you've seen and my experiences and stuff like that in the field. So I'm from the Twin Cities, locally here. Lab 651 is historically the area code in St. Paul. So that's where the name of the company came from. Been kind of always working in emerging and disruptive technologies. Got early started into web applications and stuff, doing a lot of stuff in Ruby on Rails, and had a company prior to this. We focused kind of exclusively on mobile apps around Android and iOS. But in around 2010 or so, kind of got into this idea that kind of became the Internet of Things. And in 2010, it was not really called the Internet of Things. It was really people putting things on the internet, but kind of got into Arduino, which a lot of the code you guys will see today. Has anyone written Arduino code at all? Okay. It's pretty easy to follow. In fact, that's the way it was meant to be. It was actually for people that were more novice developers. It actually came out of Italy, and it came out of a design school for people that were not software engineers to be able to build things that interfaced with the physical world. So they had like art displays and stuff like that. And people wanted to turn lights on and off and move different things. And so it was kind of written for artists in mind. Now this is, we're a good 10 years into it, and Arduino now has matured. But you can bring in C libraries, and there's all sorts of extensions to it. And obviously MXChip here and Microsoft have worked together, and they've created a platform here where you can write Arduino. So kind of worked on a lot of that stuff. I also teach a class in the graduate programs in software at the University of St. Thomas, which is in St. Paul here. And I also have a weekly news article, and we also have an organization called IoT Fuse here in the Twin Cities. So kind of very much into the Internet of Things. Been kind of working in this space for quite some time. Real briefly on what is Lab 651. So kind of built my business around this idea of connecting things. And when you do this, you sort of need 3 sort of distinct engineering disciplines. You need mechanical engineers, which we have. They are actually building the physical things. We have electrical engineers, so we can take from what is a board like this, a development board, and actually create our own printed, circuit boards, our own custom circuit boards, and then do all the connectivity, actually get all the components and stuff like that on the board, and then also do all the firmware development, sort of from the ground up, or build on top of existing systems. Like Azure in the cloud. So we can build physical devices that are out in the field that are pumping data into Azure, and then we can leverage a lot of the capabilities that Azure has, and specifically around their sort of IoT platform. So that's Lab 651. So this is the promise that Microsoft gives you, and it's actually pretty cool. There's a lot of open source, there's a lot of code out there, and it's really quite easy for you to set up your environment, right? And so one of these boards here costs about $40, and they have all the source code and stuff like that available out on GitHub, and it comes with a number of different sensors already built onto it. So one of the biggest problems that you might find when you start working with IoT is you just get a circuit board. There's no sensors that are built on it already, especially if you've written Arduino. The Arduino Uno was actually one of the first platforms like this. where anybody could start writing code. Well, you need to start sensing things from the physical world. So oftentimes you need to have a breadboard, which is literally just wires plugged into a board, and then from out of those boards there's basically current that's being sent to the various pins on the board. Well, they decided to add a number of different things sort of out of the box that sort of come with this IoT dev kit. So everything from a humidity and temperature sensor, that you might have to actually, if you build another platform, you might actually have to go out and buy one and sort of wire it into what you have. Connectivity lights too, which are pretty neat. So you actually know if you're connected to Azure. We've got a magnetometer, which we'll actually use today. I've got a magnet up here, and we'll actually simulate opening and closing a door per se, and sort of getting alerted. But stuff with magnetic fields and pressure sensors and temperature and all types of stuff. So it's a really interesting platform because it also includes outs, like digital outs and stuff like that. So there's a screen there. There's actually headphones. There's actually an IR sensor and a microphone. So pretty quickly, which is a lot of the things that we do at Lab 651, is we try and prove out ideas very quickly. Companies come to us and they say, I want to monitor X in the field, or I want to capture data from Y, right? So oftentimes what we're doing is proving viability, right? Actually getting the data sometimes can be complex, but then more interesting, of course, is what you can do with the data once you've actually acquired it. But with something like this, sort of out of the box, you want to start measuring IR, boom, you have it right there. And a lot of these things can actually be, you can literally buy a case off of the internet that you can, and drill holes in it, and you can start getting information from literally anywhere as long as you have a Wi-Fi connection and, of course, power. Right? So that is one thing that this thing is reliant upon. I can talk a whole nother hour about that, but there are a number of different other modules out there that actually are more cellular based. And this is just the dev kit. They actually support probably 100 different pieces of hardware, I would say. And if you go out on the GitHub site that I showed you, you'll see tons of vendors out there that are basically implementing a lot of this stuff here. So you're not, in this particular case, you're stuck with Wi-Fi, but there are other vendors out there that have gateways that will allow cellular connectivity. There's other sort of low range, like basically low frequency, long range. LoRa is a technology that's out there that allows you to broadcast for miles and miles. It's actually unlicensed sort of spectrum, so anybody can use it. So a lot of these other hardware players now want to provide capabilities to people like us, who are developers, to allow us to get our data into Azure and manage the IoT devices, which you'll see that's a huge component of this, is actually managing. When you start talking about thousands and thousands of devices out there, how do you manage that? There's a lot of platforms where people have built this stuff from scratch. Well, why? I would argue, why not use a player like Microsoft to help you sort of manage these devices and do remote code, basically software updates and just utilize all the microservices that Azure provides to us, right? So for $40, you can get up and running, and lots of examples and sort of tutorials on that. The thing I was going to say is, if you have a question during all this, just raise your hand. We're a small enough group here, and we have plenty of time here to basically be able to sort of talk through any questions you have. I mentioned about doing additional things too, right? So they actually sell, I don't have one up here, but they actually sell a piece of hardware where you can literally click in the bottom here, and those things are basically copper pads, and they're connecting fingers that they have there. But then you can start accessing various slots, and so this would be something where it'd be an expansion board, and now you have all these pins on top here that basically allow you to then plug additional sensors on. So you're not just limited to what you have on the board. You can expand out. Very similar to what a Raspberry Pi would offer you, if you've ever done stuff like that. There's all sorts of GPIO pins where you can start handling inputs and outputs. This is just how you configure the Wi-Fi. I've already done it. I've kind of done some pre-prep here just to basically make sure that we'd be connected. And I unplugged it since then. Hopefully it'll basically reconnect here once I plug back in again. But one of the neat things about this, too, is that you have a screen. You can provide you with feedback. The biggest problem with the Raspberry Pi, I believe, is that there's no screen. And so how do you configure these things initially? There's a whole bunch of rigmarole. You have to drop a file in a certain location. When the thing boots up, it'll try and contact your SSID that you put in there. If you put a space in the wrong place and the thing doesn't work. You always have to plug a monitor in, like I was saying. You would either plug a monitor or keyboard in to start getting these things going. This was a great idea, I would say, and it's probably one of the few chips out there or the few development boards out there where you actually have a screen that you can interact with. And you'll see in the code, we can actually literally just write to the screen. There's multiple lines there, and you can write whatever you want to the screen. So if you want to give people feedback or debug messages, you can literally display it on the screen. They've used it so you can configure the Wi-Fi with it. So you turn it on, there's a series of buttons that you basically push, and it goes into a access mode. Basically, it's its own little access point. So you go up to the corner of your screen and say, connect to this little thing, and it's called, AZ something, 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 some long string of characters and stuff like that. You connect to it, and then you literally choose, okay, here's the access points that are around me. So I chose the NDC one before I got up here, typed in the developer as the password, and the thing just reboots and it says Wi-Fi connected. And it shows you the IP address of what you're at, and then if you're connected to Azure or not. That was the other thing too, is that there's actually a little light on the board itself that lights up when you've been authenticated against Azure. Now, you certainly don't need to use Azure all the time for everything, right? In fact, this board, it's literally just an Arduino underneath the covers. It's a souped-up Arduino. It's got a lot of sensors and sort of connectivity libraries built into it that allows you to connect to Azure, but you don't have to. You can do whatever you want with the data. You can set up your own. This thing's powerful enough to run its own web server. So if you want to have this thing sitting in the corner, and you want it to be collecting data and being its own sort of request receiver as a web server, it can. Or you could literally send the data off to Amazon or anywhere else you wanted to. But they do have that light there, and it is kind of nice to be like, okay, I've been authenticated. Everything is sort of configured as I would expect. So Azure IoT, what is it? And some of this is language from Microsoft, but stuff that I agree to. It's a collection of Microsoft managed cloud services that allow you to connect, monitor, and control sort of billions of IoT assets. And there's these IoT devices that are out there. They can be everything from a circuit board with sensors, which is what this is, to a gateway, which oftentimes is collecting data from a number of different areas and then sending data up to the cloud, which you can manage gateways through Azure IoT. I'll show you in sort of the dashboard, the portal there. We won't set up a gateway in this scenario, but you can push data down to a gateway and have it distribute source code updates across the board, or you can log stuff at a gateway. And gateways are also, it's more about pushing intelligence to the edge. But through IoT, the Azure IoT, you can sort of manage those types of things. And it allows you to get quickly going. Now, I'm using an MX chip here, but you can literally use a Raspberry Pi for all of the stuff that I'm showing you as well. So if you have a Raspberry Pi and you want to go ahead and load up these examples, since it's Arduino, and you can run a lot of the same code. It's not exactly compatible, but they have a lot of examples that allow you to basically run Raspberry Pi as a gateway, right? In like a lot of these cases. So, and they have SDKs to integrate with just about any sorts of hardware. So Microsoft has been opening up more and more over the past, I would say 5 years or so, with regards to allowing other parties to get involved with what they're doing. It doesn't have to be .NET all the time. It doesn't, or C# or anything like that, right? So they actually have SDKs now that allow you to program and throw data, via Python, via JavaScript, via Java, obviously Arduino, stuff like that. So there's SDKs out there that allow you to push and pull data out to a whole sort of myriad of devices that are out there. And if you go out on their site, if you go out to Azure IoT and basically start browsing around, you can see these are just some of the examples that I had alluded to. There's pages and pages and pages of different sort of starter kits that you can get going with out there. And it's everything from a physical box, like that third one over, basically would be something for an industrial space where it can read all sorts of different types of protocols, to sort of that Grove starter kit, which are literally just a bunch of different sensors that are easily clicked into a Grove board like that. So lots of different types of devices that you can use that will probably fit with whatever you're trying to do. And like I say, for us at Lab 651, we get stuff all over the board. We have companies come to us that are in industrial space, and they're like, we want you to help us monitor. One company wanted to have us help them monitor their salt bins. So huge bins that are basically 100 feet tall or so. Want to set up sensors and sort of monitor the level of these bins. To another company wanted to monitor liquids, another company wanted to monitor people. Actually, set up cameras and stuff like that, be able to, track movement that way. So yeah, it's really, really quite flexible. And again, I think Microsoft has kind of opened it up really well to allow a bunch of devices to connect to their platform. So communication can happen over a number of different methods. Ethernet, for example, there's a number of them that just allow you to basically plug in an Ethernet wire if you don't want to trust wireless, which is fine. A lot of those applications actually, they want to have 100% uptime guaranteed, right? So what's better than an Ethernet wire connected to it? So Wi-Fi, LoRa, cellular, it's really all dependent on the module provider or the companies that actually have these platforms that make the hardware to sort of dictate what sort of communication you're going to be doing. Because at the end of the day, Microsoft just wants to sell you more services to help ingest that data and, of course, do all the business rules and all the sort of business intelligence around that. And then, leveraging all the cloud services that are out there. So data ingestion at scale. I mean, it's, Microsoft's data centers can ingest data faster than if you and I were to try and build something on our own, in our own data center. Provision different devices. They actually allow you to, roll out updates to certain subsets, which is critical in this type of thing. You don't just roll it out to all 1,000. You're going to roll it out to a couple, make sure things are working, and so you can provision them in certain groups, and then only update those sort of as needed. Visualization, so you have all the sort of the BI tools and stuff like that of Microsoft at your disposal, and then everything's talking about machine learning and all sorts of interesting stuff you can do once you actually collect all that data. So this is sort of a Microsoft sort of high-level architecture, but really, you've got this gateway, the IoT hub that I had mentioned earlier on, and that's really is what's handling the device management. That's where you register your devices. You have these edge devices out there, and again, the edge devices can be everything from a gateway to little sensors out here that are communicating directly. And then a lot of that stuff then ends up getting basically pumped through their stream analytics. So we'll use some of these ones that are here, like we'll actually create a function app. We have a couple in two of the examples that I have. We basically have function apps, which are essentially just serverless computes, right? So you can write that in whatever you want. And the examples that they show for you, I think they're written in CSharp, but you can write them in Java, you can write them in Python. But you can then, based on the data coming in, you can pull off certain events and run them through whatever you want to do with them, right? And so, really, Azure IoT is really a lot of focusing around sort of managing those devices, managing the gateway, and sort of getting it into the Microsoft ecosystem as effectively as it can. These are more technologies and solutions, right, just kind of across the board with Azure in general, right? So there's different SDKs that are out there if you start on the far left, and these are all certified devices. I mean, if you and I wanted to go out and make our own device, we certainly could. But Microsoft, in order to get on their store, in order to have you purchase it and have it be a part of the Azure IoT platform, it needs to get certified. And a lot of it is really around that security detail. So Microsoft is really, really tight on setting up private and public keys when these things start up. There's a whole key exchange that happens. They can actually help you if you want to put this into mass deployment, say you want to make thousands of these or whatever, they can actually burn the keys in at the factory. So when these things start up and they connect to Azure, they will automatically be number one provision, but then number two, just there's no chance of it being sort of a man-in-the-middle attack or being thwarted, right? The actual information was actually encoded at the factory, and so you can feel with confidence that when something connects to your hub, basically your IoT hub, that it is a device that you know about and that it's legit, right? And so, these are all sort of the platform as a service technologies that Microsoft has been building out more and more over time. And, IoT is just in some ways, it's just another way to manage things in the field and then help you to get more and more physical world information, right? That's what I talk to companies a lot about. I mean, forget about all of this technology here or things that we're connecting together and blah, 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 blah. It's really, what business problem are you trying to solve? and how can we use technology to best solve that? And so in this case, what we're talking about is actually sensing data that's in the field, physical data, analog data in a lot of ways, digitizing it, and then trying to get it to, over the internet to systems that can, of course, help us manage it and learn from it. There's also this thing in Azure. Has anyone written logic apps at all? This was a new concept to me, actually, and it's actually been out for quite some time. But it was, and I'll show you guys it. Microsoft and Amazon, they always release these little services that you never really follow. But they have it's literally just like a GUI interface, and you're like, okay, if somebody posts data to this, then go ahead and do this. And you can literally drag and drop and connect the boxes of what you want to have happen. So you can have data sent into Salesforce, you can have it sent in Office 365. They've got tweets you can do. Google services. It's really very, very flexible. And what we'll show is when the door opens and closes, I'll end up getting a text and an email. And so using this sort of logic apps, they create for you literally a URL that if you post to that, then a bunch of actions sort of happen from that. So it would be very similar to an if type thing. The only problem with I guess I wouldn't say problem, but with the logic apps is that you need the if this happens, it's always a post, right? And so if you've ever used if before, it's really powerful in that you can have something from Samsung or something from Apple. You can have something from all these different providers, and they essentially have written their own plugins to connect into this. So you could literally say, if I flip the switch on the Samsung thing and then turn on my Google Play. And that's what if allows you to do. The incoming can be any type of action that you want. In this thing, very similar, I would totally agree. The incoming thing is always a HTTP post. So that's how it needs to be. But they also do allow you to write your own connectors, I guess. Apparently they have a marketplace too as well, so us as independent developers, we can be like, hey, I have my own proprietary third-party thing, like Salesforce or like Dropbox or something like that. I want to be a part of sort of the Microsoft ecosystem because I want people to allow, because at the end of the day, you probably have a subscription service on your side. So I want people in Azure to be able to quickly sort of call into my system. You can write your own little plugins too as well. There's a drag and drop WYSIWYG interface, and it was released in 2016. I was like, how long has this thing been out? It has to be pretty new. Nope, 3 years ago. But it was kind of a neat little piece of technology that I came across. It's called their logic apps. There's this other concept called a DeviceTwin, which is kind of core to, and this isn't really a Microsoft thing. I'm seeing this. All sorts of IoT platforms are allowing you to basically do this. But it's essentially a JSON document, and I'll show you this once we fire this thing up. We'll be able to take a look at the DeviceTwin for this, but it's essentially a JSON document of the current state of what's going on the device. Now, it's not the data. It's literally sort of configurations that are going on. So it might be the SSID that's on the device. It might be you have a light that's on, and we'll turn the light on, and you'll see it flip to 1. But it's essentially a representation, and there's certain fields that you can write to, like, okay, I desire this sensor to turn on, or I desire this thing to turn off, or I want this light to be this different color. And you can do that on the cloud side. In fact, that's kind of what this is trying to show is on the cloud side, you can basically do that, some desired properties. And then the device there's essentially a socket that's connected to that, or in this case, it's actually a queue. And that information will end up getting fed to these devices. So this is how oftentimes, not firmware themselves, but device state. Like I want an update to happen, so I can flip a state for something, and then the device will say, oh, okay, this is where I go out and get my firmware. So I basically will go out here, I'll grab the firmware down, and I'll go ahead and work on it. But it's a way to quickly send messages and then get a representation. And the reason you want that representation of what's going on in the device is the device sometimes isn't online. Right? That's what happens with a lot of these devices when they're out in the field. And this is one of the things that I learned 10 years ago when I started getting into this stuff and started programming it. I'm like, this thing could be offline for 3 days, right? Or a storm goes through and this sensor's out in the field and now it has no cellular connectivity. Like, how is it supposed to react? Or should it store the data? Okay, it could, and then go ahead and send it back. But it's not like programming a desktop anymore, right? You're dealing with things in the physical world, and oftentimes there's things out of your control. There's magnetic storms that come through, and all of a sudden your sensors are whacking out, right? So you need to kind of, the way that this helps you manage is basically like, okay, here's the state of what I want it to be. When the thing wakes up and checks in, it might be 2 days later, it's like, okay, now I need to change. So it's a very, very, that's why it's called a twin. You basically have a representation on the cloud side of what you want this thing to do, knowing full well that it may not do it today, tomorrow, or the next day, but once it does wake up, it's going to check in and basically reset itself on what it should be doing. So that's the whole concept of sort of a digital twin in the IoT space. Amazon's got their same thing. Their AWS IoT does the same thing. Most systems worth their salt will allow you to they have a concept of a device twin. Anything changes on the device, I push this button here on there, the twin gets updated too. All right, so it goes both ways. But it's really a good way to monitor state of these things. I touched on functions a little bit. They basically serverless compute. They're very short-lived. They typically are stateless. As I started searching around for this, I found out a thing called durable functions. Who would have thunk it? But there actually are things out there that allow you to create these functions that will save state over time. They're usually event-based, right? So something around an HTTP call or a timer, some sort of a queue. And I'll show you 2 functions that will incorporate data that's going to come off of this. And you can deploy them actually from Visual Studio Code. So the whole platform here, when you want to write firmware for this, can actually be done in Visual Studio, or I'll be showing you guys in Visual Studio Code. So it's deeply integrated. It's pretty cool. There's commands that you can run to basically say, push this function up into the cloud, and you've already authenticated with Azure, so it'll go ahead and your function will automatically show up. So you don't need to do anything in the browser, really, to create a new function. You can do it all from the desktop and then deploy it. And you can write these in CSharp, JavaScript, Java, and Python. Like I said, they're really opening up. They being Microsoft is really opening up sort of whatever language you want to work in. So the IoT Edge is kind of where all that data is coming in and getting ingested, if you think back to our original sort of system diagram there. Actually, sorry. The IoT Edge is actually devices that are actually at the edge. Sorry, I was thinking of the IoT Hub. And so these are things that are oftentimes are gateways. They can run Linux or Windows. You can run Docker containers out there. So oftentimes, Raspberry Pi would work fine, or even a Windows 10. Basically, a lot of their edge computing devices work as well. And the whole concept around that is really trying to move logic and intelligence to the edge, right? So allowing these devices to react in real time, not be dependent upon the cloud, and then they can handle stuff when our things are offline, right? So really running, and more, we're seeing computers get more and more powerful. So this is where you'll find sort of intelligence being pushed to the edge and a lot of these gateway devices. Oftentimes, too, what I'm seeing out in the field is you don't want to send all that data, especially if it's an expensive pipeline, like pipe up to the cloud. So if you're talking cellular, prices are coming down, but still, if you've got 1,000 devices out there and they're sending data every couple seconds or so, that can be quite a hefty bill at the end of the day. So a lot of our clients are pulling that grabbing all that data, putting it into a gateway, and then really sort of, in a lot of ways, only sending up deltas, if things have really changed or not. Number one, and then number two, maybe zipping the data and just doing a bulk upload at some point in the future, or finding other ways to do it, right? So it's really, the cellular is really we term it as a cellular backhaul. So we try and use Wi-Fi if we can. If we can't, then we flip over to cell and we start using cellular. Like, hey, I'm not connected anymore. Something's going on with the Wi-Fi. Probably want to fix this, but yet I'm still sending you data, right? So you can do a lot of that stuff when you're out at the edge with the gateway, and Azure IoT Edge allows you to do these remote deployments to these more intelligent devices that are out in the field. You can deploy and manage them, and of course, again, sort of all sorts of different languages are supported. So I'm gonna start here with this sort of first example here. We'll see how this goes. So I've already gone through the steps of getting it on our Wi-Fi. Hopefully it works. And I'm just going to go ahead and plug it in here. And what's popping on the screen right now is it says connecting to Wi-Fi. So it's going to try and connect to the Wi-Fi here. I was going to try and, let me see if I can hop out of this real quick and kind of walk you through what one of these things does, or what sort of one of these tutorials walks you through. So here's sort of what we have here, and I was going to bring a second one. I forgot, just so I'd kind of pass it around, touch it, and feel it. But when we get done with this session here, feel free to come up. You can see what they look like. But kind of I've gone through the steps of basically getting the thing connected and set up with the Wi-Fi. Which, yeah, it's connected now, and the code that it's running is basically the startup code that I have on here, and I'll walk you through that. That's all basically running Arduino. For a second here, sorry. What is this thing doing? So yeah, it's actually, I had turned on, here's our logic app that's right here. I'm going to turn it off. It's actually texting me when it's not supposed to. So I'm going to go ahead and turn off these functions here. So what we're basically going to be running here, so what you do is, this is Visual Studio Code. You can go ahead and download one of their examples, which was on this site here. What this walks you through is basically getting your IoT device set up. And I named mine MX Chip 1. And I went out, created a device in IoT Hub, which I'll go ahead and show you guys out here. If we go out to our NDC Minnesota resource, yeah, here's our Lab 651 NDC. So I went out here, I created a new, if you go ahead and take a look at the devices, you see, IoT devices that are here, you'll see our MX chip is here, and so this is what I named it. And so these are the connection keys that you use, basically authenticate against it, and that's what this step here is basically making sure that you have your keys set up, and that it can essentially connect to the hub on the back end. Here's the steps too that I had kind of shown earlier about putting in your Wi-Fi, SSID, and password. And I'm just kind of showing this just for the sake of just letting you know that it's well documented with regards to how you sort of get set up and what sort of pieces you need to go ahead and add and plug in. They support Windows and Mac, Linux. Ubuntu is supported as well. Basically any place that you can run Visual Studio Code will basically work. So the first project that they have you do, and again, there's a whole set of tutorials that are here that you can use, and I started out with the Getting Started one. And if you've done any, I guess one gentleman has done some Arduino programming out there, but in Arduino, there's really only two functions you need to have. One is called setup, so this is going to get run once at the beginning, and then there's a loop function. So the microcontroller will just sit there and loop through this until it loses power. So what you'll have inside this loop here is where we have checks. Does this thing have Wi-Fi? They basically, and then on the display, we go ahead and show what happens with the temperature readings. Then we wait a second, and when you print to the screen, which is what we see on here, right now, it literally says count, like 43 out of 43. It's just sort of counting its way up, and then it says temperature 26 and humidity is 29, so which is in Celsius, and so those values are literally just being printed whenever we hit this device client check. And then if there's a temperature alert that happens, then we go ahead and send out an event. And so when this thing is sort of plugged in right now, we should be able to see events that are being sent out. In fact, as this thing is looping through it, yeah, the counts are going up and the data is being sent out. So at the beginning, when this thing was set up, this is what it showed. It showed that the dev kit was initializing. This is sort of the baud rate at which it's communicating over the serial port to. So if you want to write anything out, again, you can basically do a serial.print, or you can print stuff to the screen. So these are the things that you basically see at the beginning of the screen when it gets sort of set up through its first time. And these are other, you can kind of walk through how some of these callbacks happen, but it's literally just sending data, and this is what it's being sent out over time. So this is being called each time through that loop function. Now, when you have the MX chip here connected, you can basically say, you can click on one of your devices. And again, this could be any device, but right now, this is the only device that's plugged in or that's actually communicating with it. And you can just say, start monitoring device to cloud messages. So this thing will start up here, and we should start seeing, there's probably a difference. So this is the other thing that happens too, is if you have multiple functions that are being run or connected on the queue, then you just will want to stop one of them. So let me go into our NDC state function. Let me see. I'm taking a look at our, taking a look at our functions that are here, and I'm going to stop the functions that we're not using. So here's a door monitor one, which we'll get to that one on the next step. Let's stop that guy. What's that one doing? Okay. Let's see if we have another function running. That's the door monitor one. Okay, this should work now. So let me go ahead and stop monitoring. And I'll start monitoring it again. Let's see if this works. Oops. Okay. So here's essentially the message. You guys can see it. Here's basically the messages that is being sent from the device off to the cloud. And this thing is just getting published, and it's getting published. Should be getting published around every second or so, because at the end of our loop that we had here, we just have a delay of 1,000. So as it comes around here, it does the check, publishes out what the message ID is and what the humidity level is. So this data, this kind of shows you that this is what's basically being sent up to the cloud. And if we want to, when you're over here in your, where is it? It was our IoT hub. If you go in here, we can actually send a message down to the device. So we'll try that as well. Again, we're connected to Azure there. And if you actually, this is kind of cool because you can actually pick out any device that you wanted. It's out in the field for our IoT devices. We can click on that, what's there. Now we can take a look at the DeviceTwin. I'll talk about that real quick too, since we're already in here. This is the current state. So this is basically, there's a light that's on here right now. You can actually see it. And here's the RGB and red, green, and blue values that are set. And if I change those, that'll change down there too. Does that make sense? So you can turn lights on and off here. I can turn the state of these lights on and off by literally just putting a 1 in here and then saving it. And these are values that just sort of get out of the box, right? And here's the Wi-Fi, here's my IP address and the SSID of various ones that were reported at various times the last time that the device was sort of brought up. So if I go to device details here, I can be like, let's actually send a message to the device. This is how you can sort of check. And you can probably send anything you want. I typically just send, some JSON to it. And if I go ahead and say send message, if I go ahead back here and take a look, I'm basically looking at what was here. Let me stop monitoring. Device to cloud. for where I actually saw it because I had seen this before in the past, where you could actually end up getting the messages coming through from the device if it's connected. Must not have the right console up right now. And this is where it's like, if you're making sure that you're actually seeing the right terminal or the right console can be. But I was able to send messages in the past, so I just want to make sure that this thing is actually, let me just refresh it. There it is. So when you're over here on this thing, you can right-click and you can basically say Start Monitoring Device to Cloud. So basically anything I was sending off the device, which is what we were showing here, this JSON being pumped out, or you can start monitoring cloud to device. All right, so the moment I flipped on Start Monitoring Cloud to Device, then basically I could start seeing the messages that were being received here through this output terminal. That make sense? And then you can turn it off anytime. You can basically say, okay, I want to stop monitoring this, these sort of devices. So I had stopped it. That's why you weren't seeing anything that was coming through. But that's how you can pump messages down. And through the DeviceTwins, we can actually turn lights on and off remotely, which will actually be a part of the next thing that we do, our next sort of example. So that's basically the getting started. And I mean, within the matter of 5-10 minutes or so, you can get yourself online. You can configure your device in the IoT Hub, and you can run one of these examples. And literally, the way that you run it is, they've got a pretty cool sort of like, I want to start typing upload device, or a pretty cool like find and search. So you can just say upload device code. And what this thing does, it actually runs the Arduino. They've leveraged essentially all the Arduino setup and configuration, which is great. They didn't try and reinvent the wheel. Arduino has its own graphical user interface, sort of IDE, that allows you to write code. So they're writing on top of that. So they're literally just firing up Arduino in the background and doing all the compilation, verifying everything works, and they're saying uploading the sketch, getting started.ino is their thing. And then, it's basically going through its restart now after it's uploaded the code. So for any Arduino developers or even C programmers, this is like very similar to what you would be doing. So that's sort of a quick start on basically getting your first device, sort of up and running. And really what we all did was just verify that the JSON was being sent to Azure IoT, and then we actually also saw the other way. We also verified that we sent some JSON back to the device and saw that it showed up in the terminal. I want to talk real quickly here about just setting states. So I talked a little bit about the DeviceTwin. We'll actually go through it now here. This is based on another one of their sort of examples. And it's kind of cool. There will be a web page on my computer here that will allow us to basically turn lights on and off. And you'll see it's just kind of a mock of a board. But you can change the colors and change the lights. And really what's happening is a message is being sent to the IoT Hub. The IoT Hub is calling a state function that I'll show you guys that literally just updates the DeviceTwin. And then kind of Azure IoT or the DeviceTwin and sort of the backend code sort of out of it, because it's up to IoT Hub then to basically be like, okay, this thing's been updated. Go ahead, run through the normal DeviceTwin update, whatever like normally happens, and then the MX chip basically will respond to that. So it'll go ahead and get a new set of configuration down, and it'll say, oh, I need to turn the light on, or oh, the light needs to be green, not red. And there's sort of, it's an RGB type light, so you can see we'll be able to set various thresholds. But that's literally what this sort of example shows, is being able to flip state. And this is running on my machine, but this web page could literally be running anywhere. You could put it out on a web server, and somebody else from around the world could basically start clicking it and updating basically what's going on the device. And we're turning lights on and off, but that could literally be logic that you could be calling to change things, to call different routines, for example. I mean, the moment you can actually interface and flip and change parameters on the device, kind of the sky's the limit. There's a lot of cool stuff that you can do. And I'm showing you guys more visual type stuff, but there's a lot of underlying changes that you can do to these devices just by the mere fact of having access to their state and their DeviceTwin. So, yeah, so really I'll load up a browser interface that calls an Azure function, and I'll quickly cruise through that function as to sort of what it does. But at the end of the day, the DeviceTwin is really what's being updated based on the parameters that are coming in, and then the board will respond sort of in kind. Any questions so far? Any of this stuff? And again, this is an example that they have here. So if you go out to the GitHub page, and a lot of this, I will say, I'll stop here for a second too. A lot of this sort of the provision, the Azure services, these are just one-time things, right? And even the sort of the deploy to Azure. Once your function is up there, then it will literally show up, which we, as I was hopping around there, you might have seen some of the functions. But we had one that was. Let me go into, and all this stuff is under a resource group called NDC Minnesota. We basically have an NDC state function. So this function was deployed. It was actually deployed directly through the Visual Studio Code, and then it basically runs out here. And I'll open up Visual Studio Code for that project. In fact, if we go open recent, we'll go to the dev kit state. And this one's a little bit more interesting in that we have this index.html, which is going to be our page. There's some updating that happens. So this is the other thing too. There's new code that's part of VS Code. It'll go ahead and update it. But there's an index.html page that will go ahead and run in our browser, which is this. And this is a simulation. I wonder if this plus make it bigger is going to work. Cool. Which is essentially us configuring the HTML page to say which function am I going to call out in the cloud, right? And so we'll drop that function name into this thing. The other thing that we have is our state. So here's basically our state function, which the only thing that we really needed to do was just actually tell it the device name you want to have it update. Other than that, this is pretty simple code. It's basically going to be calling, it's basically taking in JavaScript from what happened in the field, and then it's setting those parameters on this DeviceTwin. Is really all that's happening here. So if we look back at what we did here, this state function is what's getting called, and it's taking the MX1 and updating it based on the user LED, the RGB stuff, based on the things that we click on. And I think it'll make more sense once I actually connect it and set it up. But you've got an HTML page that's making calls. You've got our CSharp, basically function that's running out in the cloud. And I deployed that sort of through, kind of following these steps to say deploy to Azure. Once it's deployed there, I don't need to keep deploying it. And these are the connection strings that were all set up before. And then you can basically update the code. So what we'll do is we'll go ahead and push this Arduino code. I won't get into too much detail on the dev kit state Arduino. Really what its sole mission to do is basically take the values that come in and go ahead and update like the RGB LED values. It'll also update what the firmware value is and stuff like that too. So it's kind of really reliant upon we're really changing something on the DeviceTwin, and then this phone this device is really just going to be doing what it's told. So we'll say upload device code. So right now it's going through. It's going to launch Arduino. It's going to push this INO to the MX chip kit right here. It's restarting now. Actually, it'll say it's blinking right now. It's probably in the process of flashing it. So it's uploaded it and it's done. Now it's reconnecting to the Wi-Fi. So the name of our function that we had, recall what that was? It was out here. We had created this NDC state function. So I'll go ahead and grab that, and I'll drop that in right here. So right now, the browser is trying to connect out to our Azure IoT hub, basically. And if it's able to get out, let's see, Minnesota 2019. Oh, sorry. This function was not started. So this is one of the things that you can overlook. Oftentimes, I'll start and stop functions because they don't need to be used by anybody. But there's this NDC state function that's here. It's started up, it's running now. Let's see, I might have to refresh the browser and try it again. No, it's there. So again, like I said, this is just basically a web page that is going to be tracking clicks. So if I go ahead and click on this, for example, it's going to update the DeviceTwin on the back end to actually turn the RGB LED on or off. So let me see. I'll go ahead and click on it. Oh, sorry, right here. I'll go ahead and click on that, and then the light just turned on. I'll go ahead and click on it, and I'll click it off. Light just turned off. So what's kind of fun is that we talk about device twins again. Let me go back here to our IoT hub. We'll go ahead and take a look at our devices, our IoT devices that we have here. And we'll take a look at our device twin. And this thing is our user, I think it's our user LED state, or RGB LED state. So what I'll do is I'll go ahead and click it on here. Went ahead and turned on. And my expectation is if I go back out to my device twin and I refresh it, then this thing's flipped to 1. That makes sense? And for fun, I mean, we can do other fun stuff. We can be like, well, let's actually make it be blue, be 0, and let's crank the red up. So yeah, the light just turned hot red right now. If I go back out here and refresh my device twin again, it's 255 for red and 00 for the other ones. So, and for fun, I could just go ahead and drop in 255 for here, forget about the web page for a second, if you just basically say save, and then refresh it, yeah, it just turned white. Basically, RGB's turned on all the way. So it allows you to, once again, sort of, you can change stuff. This just makes it nice because it's kind of more interactive. It's kind of fun. Oh yeah, well, let's go ahead and turn this light on or off. So I just see that light turned on and off. But it allows you to, and allows you to also sort of see what information is being piped back, right? So here's the SSID of where we're connected to, our SSI strength. That can be important too. I mean, with regards to intermittent connectivity, you should be logging that along the way. And if you when you do have connectivity, you can send it back and be like, we have flaky Wi-Fi here, right? So there's a lot of data that's sort of already on this device that we're just going ahead and just showing on the screen. So that was the device. Does that make sense for the state? The last one that I was going to show here was this sort of door connector. I want to make sure, I'll just kind of try and rip through that real quick because I want to make sure we at least have a couple minutes for questions. And this one is actually, that was our state example. So this one sort of uses the magnetometer to basically sense if there's been a magnetic change. And so I've got a thing here that I'll bring close to it, and you'll see the magnet value change. And we'll go ahead and send a message through the IoT hub. It calls this door monitor function, which is the same thing as the state was, right? There was a function that's basically being called. This is where we'll drop in the logic app, and we'll go ahead and send through SendGrid. We can send SMS or we can send emails for data that was coming in. So, and what happened earlier was I ran that temperature thing, and it was pumping temperature data in. Well, it was firing through this exact same thing here. That's what happened. So my phone started getting text messages. I probably got a bunch of emails that say that the temperature had changed, right? So, so we kind of exercised the back end of this already a little bit, probably over-exercised it. I probably got about 100 emails and text right now. But this will basically be allow us to kind of, you'll be able to see, hopefully, as I put it up close to it, it'll flip state, and we should start seeing some stuff come through. And again, let me see here. Most of these examples are all online, and this one's called their door monitor. That's out on their GitHub page. If we go here. And really, like I say, a lot of the stuff, most of the stuff that's changing per se, I'll open the source code, it is really just the function that you're going to call along the way. And then really what happens when that message sort of comes through. And in our case, we are going to, as I mentioned, let me go back out here, we're basically going to be calling our logic app. So I have this NDC door monitor. Let me go to our resource group. I have this NDC door monitor function, which is sort of doing the exact same thing that the other one was doing. It was taking a message that kind of came through, and it's called door monitor. Here's the CSharp thing for this. And all this thing is doing is literally just going to be posting to this URL, this long string URL that was here, central.uslogic.azure.com. And what ends up coming out of that one is that's essentially our logic app, right? So we have this NDC logic app that's here, and here's the data that has basically happened in the app. If you ever click on edit, for example, this is what I went ahead and set up. I sort of talked about that WYSIWYG programming. So you can say, oh, when an HTTP request is received, then we will send a text message, and you can choose who you want to text it to. This is my send grid information and a text coming from, and this is my phone number. Or when we send an email, we'll send an email to my Yahoo account. And that's literally it. And you can branch these things as much as you want, based on when the email comes back. You can have it do something else. So this is sort of the Logic Apps Designer that I was talking about, that allows you to pretty easily, based on an HTTP request, do something different based on what was there. And so then I have my door monitor. This is just going to be basically going to be outputting right now, current the sort of the X, Y, and Z values that it's picking up from the sensor. And again, for some reason, this is just the example, so they called it X, Y, and Z. But when you put a magnet close to it, the values change. And once they change enough, then your function ends up basically getting called. And that happens somewhere else. So this is the initialization process that happens. Oh yeah, here, and if there's a change that's basically happened, then there's a door status is going to be flipped to open, and that message is going to be actually sent over the serial bus, which I'll put it in the serial console, so you'll see it come through. But then we'll also actually be sending out the event over the MQTT Client, which is how we message stuff out to Azure IoT, to the IoT hub. So I'll go ahead and it's just F1 to have you sort of bring up the list of recently used commands. We have upload device code, so we'll try and push our door monitor thing on here, so it should take a second or so. The other thing that we're going to want to do is make sure we have our function running. So if I go back out to NDC Minnesota, our state function, I definitely could keep it running, but I'll just stop it for now. That was the one from the prior example. If we go in here and we'll go to our NDC Minnesota door monitor function, and we can go ahead and start. We'll go ahead and start that guy up. So that thing's been started. It says initializing the magnometer, which is it's counting down, and then I got some numbers that are basically showing up on there right now. So it's basically running our loop code, and it's just the numbers aren't changing at all because there isn't a magnetic field that's coming through. I think, let me see, if I go to terminal here, oops, sorry. I go to output, and I go to my serial. Serial monitor for what's here. I just wanted to see if the serial monitor would basically show what we're, because you can do serial.print, you can print stuff out. I'll go ahead and, and the other thing I need to make sure that I do have running too as well is our logic app. So you basically want to enable that. So if I end up moving this thing close to there, that just said, yeah, sent message. I just got a text on that, basically based on the door closing and the door opening. Yeah. So that's an example of basically being able to send data through, and you can take a look here and see here's some ones that are coming through here at 212. It's usually off by an hour, actually, by the ones that are there. It's not instantaneous, but here's ones that are coming through now from sort of 240 that we had running. So that's how you can basically end up getting data that's sent to a function. That thing can basically get sent off to your logic app, and then sent off via that chain that we saw to our SMS services and our email services. So hopefully that's been interesting, useful. I've really enjoyed utilizing this platform, not only for my own personal use, just for like fun stuff that I have sort of around the house. Because you can have it sense the light on, so I mean you could have something as sort of simple as when you come home or your wife comes home or somebody comes home, they turn the light on, this thing will know somebody's home, send a text message, right? And a lot of this stuff is super easy to just sort of configure and set up and then sort of tie all the services together. We haven't even gotten into a lot of sort of the data streaming stuff at all, a lot of the real-time stuff and really building out, dashboards and all that sort of stuff. I mean, that's sort of like the next phase of this is sort of building something on top of sort of a Cosmos DB or any sort of time series data that you might want to start firing this data into. But I thought it was interesting enough and just kind of get your feet wet. This was sort of around the foundations of sort of Azure IoT and some of the pieces that you can sort of plug together. And hopefully you guys found it useful. So any questions right now? Anything? I know we're like right at the time limit here, but I'm more than happy to share anything that I know. So in the back, yep, we got one. To the other devices? Well, I mean, so if you have, so I think from what I understand the question is like, how can these devices connect to each other that are beyond just the dev kits, I guess is what you're saying? Yeah. And so there's, I mean, I think the dev kits are great, and they're a good sort of a great place to start, but like, are you thinking about like, how does this interface with like a Google Home or something like that? I mean, so look for devices that actually have open APIs to them. A lot of these, like Alexa and like Google Home, Samsung Smart Things, they've got a lot of stuff that you can do. Basically, it's a very open API. So yes, you could have a pretty simple device out here, but the moment that thing can get on the internet, you can do anything. I mean, quite frankly. So I try and basically say, like utilize the cloud as much as you can for this. Don't try and go to device, because oftentimes those are a lot of proprietary protocols. You don't really know what's happening there. But look for other devices that are that are open in the ecosystem. There is an interesting project out there called OpenHab, which I would highly recommend sort of taking a look at that. And that's like it'll run on like a web server that's local within your home. But then they have extensions and plugins where you can sort of kind of do a lot of this if type stuff that I'm talking about. It's all open source, and a lot of it is actually sort of WYSIWYG drag and drop. So you can start plugging these devices into each other sort of through an open source interface. But I would say if you're just sort of getting started at home, look for devices that have open APIs, and if you know enough programming to be dangerous, then you can sort of just plug this stuff together and do some pretty fun stuff at home on your own. All right, great. Thank you very much, everyone.